Well, so like I'm trying with them. Now that we're recording, so talking about it. Like I think I told you guys, the juniors right now in pre-cal are doing the first unit that we did in August, but I'm making them watch the videos at home and then coming in and we're practicing. Yeah, I mean they're doing it. They're watching it, right? And they put their cell phones away. Like I have them put their cell phones away before we start. So, like it's working out. So, well, it's also me making sure that they are, right. If you guys walked in my class from day one, I said put all that stuff away. You're probably going to be awake, maybe. Ready? All right, let's talk about Brandon and Chloe. Our friends, Fernanda, Brandon and Chloe, our best friends, and they're riding their bikes. Wow, for 4 hours, that's a long time. It's a long bike ride. We are not given Brandon's actual function. We're given values for his function in a table. We're not actually written out the function. It does say it's differentiable. All right. And it says that this is about the velocity. All right. So remember, think of our like PVA. So they're giving us the velocity function. Everybody go there? Now with Chloe's, same idea, but with Chloe's, they're actually giving us the piecewise function for this. So Chloe's velocity function is down here in this piecewise function. Okay. It says how many miles did Chloe travel from when she started, so times 0, to 2 hours. So halfway along her bike ride, how long has she traveled? Right. So remember, where are we in this idea of PVA? Where are we? We're at the V for velocity, velociraptor, right? So if we want to do how many miles, right? So this is miles per hour. If I want to do just miles, where do I have to go? I got to go up. I got to go backwards, right? I have to go backwards to the position function. So what does that mean I need to do for this piece? Well done, Cameron. I need to do the antiderivative for this piece. Why did I choose that piece? Why did I choose that piece? Why did I choose that specific piece?
Oh, because that's the one we're talking about.
Because it says 0 to 2 hours, right? Do you guys see that? All right, so make sure you choose the correct piece. All right, so let's do the antiderivative of that piece. So the antiderivative from 0 to 2 of t times e to the 4 minus t squared. And this is her position function. Okay, what do I always do whenever I see that natural exponential function? What do I always do? Whether I'm taking the derivative or doing an integral, I copy it. Very good. So I'm going to copy it down. So e to the 4 minus t squared. So just as like a little aside here, if I did the derivative of this, what would that be? What would happen if I did the derivative of this natural exponential function? Copy it down. And then what's the derivative of our exponent?
2t.
Careful, you're close. Negative 2t. So it'd be this, right? And remember, what do I want it to be? What do I want it to be when I look back at my original? What do I want it to be? Just t. So what do I need to put here so that way this is just t? A negative 1/2 to the reciprocal of 2, which is 1/2. So I'm going to put negative 1/2. All right, I'm evaluating this at 2 and 0. So let's plug in 2 and 0 to this. Times e to the 4 minus 2 squared. Okay, what is 4 minus 4? 0. So this becomes e to the 0 power. And what's anything to the 0 power? Just 1. So this becomes 1 times negative 1/2. So just copy that down. Negative 1/2. Okay, minus. What's 0 squared? 0. 4 minus 0 is going to be 4. So you could write it like this. This is the answer. All right, or you can clean it up and write plus 1/2 times e to the 4th power. Well, you know what? I should put some units here. What were the units? Miles. Just miles. Why is it just miles, Andrew? Remember, we went back to the position function. So this is how many miles that we expect Chloe to have traveled halfway on her bike ride. Now, that probably doesn't mean a whole lot to you. Doesn't mean a whole lot to me either, right? Negative 1/2 plus 1/2 times e to the 4th power. I have no idea what that is in terms of like how many miles. All right, let's see. E is approximately 2.7183. 2 to the 4th power over, so about 20 times 10. I mean, maybe this is around 8, 9 miles. Okay, just do a quick estimation. All right, that's a long way. 10 miles? Goodness gracious. Say it again. Approximately 2.7183. Right? Remember the Beastie Boys song called "Girls"? Heard that song? Girls. It was a long time ago, way before you were born. There you go. Yeah. So but instead of the girls, you say E. That's 2.7183. We made that song in calculus when I was a senior. I need to ask my friend Brad if he still has that song. We were all in band together in high school, so we went to the band hall and like made the song. We did a lot of songs. We did a lot of projects back in the day. Yeah. The quadratics, quadratic formula. Yeah, that one I did was to Fergie's Glamorous. That's deep in my YouTube channel. Search for that one. Enjoy it. Enjoy us. Gonna find it. You remember it? QUADRATIC. I'm solving functions. No.
In my class.
I recorded that right over there. Man, I was like 20. Gosh, I was like 24. Was it 10 years? Yeah, definitely 2 years ago. Mm-hmm. That was 10 years ago. Okay. Have I ever showed you? We should do this after the AP exam. Have I ever showed you Candace, Samina? What was her name? There's another girl in this group, and they made a song about the quadratic formula to Gangnam Style. I'll show you that video. I had that somewhere on my computer. I'll show you that one too. Oh, that's magic. Just magic. She's got her photo. Candace has got her photo somewhere one of these hallways. She graduated from Boston College.
Oh, yeah.
She did what?
She went to came talk to us, and then she quoted her speech how like the first day she walked in, she brought a rocket backpack or something.
Oh yeah.
And you were like, you're ready to like.
Oh, take off.
Take
Yeah. Yeah. She was great. I mean, listen, Edder's awesome. There's no Candace. Okay. Let's do B. At time t equals 3 is Chloe's speed. So she's on the bicycle. Remember, she's on the bicycle. So this is 3 hours after she should have been on the bicycle. I would answer this question without calculus. She's clearly decreasing her speed because she's been riding her bike for 3 hours. But you'll see it's not. Anyway, so the way to do this is to find what her velocity is and what her acceleration is. Okay? So let's find her velocity. They gave us the velocity function, but now we're at t equals 3. So what piece do I have to use if we're 3 hours into her bike ride? The second piece. So I'm going to plug in 3 here. So C of 3. I think it was 12 minus, is it 3 times 3 minus 3 squared? That's right. Sure. Yes. Okay. Let's do quick algebra here. 3 times 3 is 9. 3 squared is 9. All right, going left to right, you get -6. Let's get some units here. Miles per hour. Nice. Okay. Let's find her acceleration. Now remember, in the world of PVA, where are we right now? We're at V. And how do I get to A, the acceleration? The derivative of it. So I'm going to do the derivative of just this piece, right? So ddt, bless you, ddt of 12 minus, I think it's 3t minus t squared. Okay, so what's the derivative of 12 minus 3t minus t squared? I'd like the minus 2t part. It's going to be -3 minus 2t. Okay? Yes. Now this is the derivative. So what is this function? How would you describe this function here? If this is the derivative of velocity. Israel, welcome. What is it? The derivative of velocity? Derivative of velocity. I guess I should read it. Acceleration is right. Very good, okay? So know that we're talking about the acceleration here. So if we plug in 3, so 3 hours after she starts, did I make it? What? 3, I should go play the lottery. 3 hours, don't do that. Statistically speaking, don't do that. 3 hours after she starts riding. So let's see. Whenever I go to like Circle K and people in front of me are buying any of those like Texas two-step or lottery tickets, I'm just stop. Save your money. Okay.
What if you played it one day and you did more?
We did. I tell you guys we gave, I think I told somebody, some class, we gave my children's teachers like some little scratch-offs from Circle K saying like, we're lucky to have you as our kids' teachers. And one of the teachers won $50. She was like, oh my God, you guys are the best. Yep. All on a ploy to get you to love our children. Okay. What's the acceleration? What's the acceleration? -9. Give me some units. Yeah, those physics people love it, right? What is it? -9.8 meters per second squared. Right? Isn't that the gravity? It's been a long time. Been a long time. Right? There's a reason I don't do anything with X in it. Okay, well, let's talk about this moment. So right now we're saying, what is her velocity at 3 hours? -6 miles per hour. What is her acceleration? They're both working together. You see how they're both negative? If they're both negative, if they're both the same sign, in this case, they're both negative. If they're the same sign, then her speed is increasing. I know. That's the weird part. If they're working together, okay, if they're working together, then her speed is increasing. You're welcome. Okay, so what if they were both positive? What if they were both positive? Increasing. They're working together. They're the same sign, Andrew. If they're the same sign, speed is going up. Speed is increasing. What if they're opposite signs? Then they're working against each other. Her speed is decreasing. Okay, so her speed is increasing because her velocity and acceleration are both negative. Who are you talking about, Chloe?
Yeah.
All right.
This is where my question comes in. Do we get credit within part of the work?
Yes. So the key, I'll pull it up later, but the key I think is a point for finding the velocity and the acceleration, then a point for having the correct conclusion. So Joel, in this one, I would say there is a sentence needed.
So what if I just put it increasing?
It says why. Give a reason for your answer. Sorry, not going to work, right? Give a reason for your answer. Reason. There it is. Reason for your answer. I don't think they do half points. Any questions on B? Bless you. Any questions on B? Okay, let's do C. All right. Is there a time t at which Brandon's acceleration is equal to 2.5, and my favorite part of calc, miles per hour? Justify your answer. This question, what I'm going to use to answer this, I know I'm going to write miles per hour squared. I'm going to use the mean value theorem to answer this question. Let me try to explain this the best I can. So when it shows up there, you'll see it. The mean value theorem. All right. If we have a continuous function, and I'll show you in a moment how we know this function for Brandon is continuous. All right. And we find the average rate of change, which we'll do mathematically here in a moment, the average rate of change for that function. Okay. If it's equal to this number they gave us, then at some point along the hours of 0 to 4, all right, at some point the function would have to equal, right, that value for the acceleration. So let's find the average rate of change first. Okay, so here's how you find it. You take the largest x value, in this case it's a t value, so I'm going to do b of 4 minus b of 0 over 4 minus 0. And we actually did this a couple problems ago, I think on number 3 in part A. All right, so look at the table. You're going to have to flip back if you're going to look at the table. But at time t equals 4, what is Brandon's velocity? What was it, 11? 11 miles per hour. All right. At time t equals 0, what is the velocity? 1. All right. So 11 minus 1 over 4 equals, all right. What is 10 divided by 4? You probably know. You probably know. You probably know. You probably know. Right? It's 2.5. Right? It's 2.5. Okay. So now here's the deal. It says in the problem that B of t is differentiable.
Where's that at?
In the problem up here? Right here. Brandon's velocity in miles per hour at time t, so B of t, is given by a differentiable function. If it's differentiable function, if they tell you it is, that also means it must be, so must also be continuous. So we don't have any like removable discontinuity or jump discontinuity. We don't have any of that discontinuity happening. Okay? So that means using the mean value theorem at some time t, Brandon's acceleration must equal 2.5 miles per hour squared. Now, we don't have a ton of time left before you take the exam, but we do have some days, and you do have a weekend, right? I obviously don't know what you're doing with your life on the weekend, but I would encourage you, all right, to go to AP Classroom, all right, look at all those videos that are there to help you, and find the one that's about the mean value theorem. Would it be helpful if I assigned it to you? Would that be helpful if I went and assigned it to you? I can do that. No? Only one person's nodding. Yes? Okay, so what I'll do is I'll assign, before tomorrow, I'll assign the mean value theorem, and in a moment you're going to see in letter D, we're going to read about or talk about the intermediate value theorem. So I'm going to assign both of those so you can kind of see how that works, all right, and listen to it from a different AP Calc teacher, all right, because you guys know it's my first year doing it, so I clearly don't know a whole lot about calculus, all right, but man, in 7 years, woo, goodness. You have no idea. Thanks, Michael. That was not me fishing for compliments, right? But I appreciate that. Let's do D. Just showing you that I'm always trying to improve, just like you guys are always trying to get better, right? Okay, letter D. Okay. Is there a time T between 0 and 2 hours, so halfway through the ride, 0 hours to 2 hours, halfway through, at which Brandon's velocity is going to be equal to Chloe's velocity, okay? So here's the justification we're going to use here. This one is going to be the intermediate value theorem that we're going to use, okay? What I'm going to first bless you is because B of t and C of t are both continuous, you can do B of t minus C of t. Okay, you can subtract them. Right? And this goes all the way back to when you guys were sitting in this room 2 years ago. Not you, but 2 years ago when you did operations with functions in here. Okay? So if I were to do subtraction, all right, and plug in my endpoints here. So I'm going to plug in B of 0 minus C of 0. Let's get a C there. See what that is. And then B of 2 minus C of 2. All right, let's get our values. Go to the table. I think you already told me this one. At time t equals 0, what is Brandon's velocity? It's 1, right? You can show your work here, but I think we can do this mentally. If we plug in 0 for Chloe, which piece am I using? Wait for it. Which piece am I using for time t equals 0 for Chloe? The one I've actually highlighted, right? So I plug in 0 here, all right? What's 0 squared? 0. 4 minus 0. So e to the 4th power times 0. What's e to the 4th power times 0? It's 0. Awesome. So this is 0. All right. So if I subtract their velocities, bless you, if I subtract their velocities, right, at time t equals 0, what do I get? I get a positive 1 miles per hour. Okay. Let's do the same thing for 2. All right. Go to Brandon's table. What is Brandon's velocity halfway through the ride? 1.5. All right. Let's go to Chloe's function. Okay, here's Chloe's function. 2, where am I plugging this in? Be careful. Where am I plugging in 2? It says or equal to 2, so stick with the same one. You're good. Stick with the same one. What's 2 squared? 4 minus 4. Anything to the 0 power is 1, and 1 times 2 is 2. So her velocity is 2. And what happens when you subtract 1.5 minus 2? Very good, miles per hour. Okay, now watch this. All right. So if you notice, at time t equals 0, all right, we have a positive 1 mile per hour. What happens at t equals 2? We have a negative half mile per hour. Okay? So at some point, we've got to go from positive to negative. So at some point, we've got to go from 1 to negative 0.5. There is a number in between here that I care about. What is it? 0. Why 0? Because if this minus this is 0, that means they're what? No, if this minus this, I love you trying. It's not they are continuing. But if this minus, somebody said it back there, was that you, Michael? If that minus that is 0, that means they're what? That means they're equal to each other. All right. So at some point between 0 and 2 hours, Brandon and Chloe will have, and you could say the same speed. Michael, that's right. I'm going to put the same velocity since we're dealing with velocity functions. Do you have a cell phone?
Yeah, I went to the report and I've gotten taught in physics.
We talked about it in physics.
You've gotten caught in physics?
I've gotten taught.
Oh, taught in physics. Well, let's see. I've got Google. All right, what am I doing? What's the difference between velocity and speed? Okay, let's see. Why don't I stop my recording first?